All right, how's everyone doing? Any luck? All good? Yeah? Ish, yeah? Okay. Oh, I see, okay. Is Elixir all running now? It's good? Okay, great, okay. I'll just pop into my REPL just to make sure we all get a solution. All right, so I have one, A, foo, sure, why not? So there's this map function. The first argument is always going to be, or the convention is, you have whatever this element is about. So this is enumerable things. Lists are enumerable. So we're going to map that with inspect. Oops. And it'll print out all of them stringified, and the string has escaped quotes on it. I feel like, so I've been asked, is there some way to get rid of those? I feel like I've done that, but honestly, I don't really inspect a lot of stuff in day-to-day work enough that I think there's a way, but I can't remember. And I can look it up at the break. Okay. So some more conveniences. Multiple function heads, which you may have seen in some other languages. But if you're coming from, say, Ruby or JavaScript, this is very bizarre. We've defined the function twice, this div. And in the first one, we're saying 0 as the second argument, and the first one, ignore it. And the second one, we actually capture the values. And then we have two do's. So in regular div, we can't divide by 0, and this will give us an error. But we're saying in this case, we're going to be very permissive. Never do this in production, please. We're going to be very permissive and just say 0. If the second argument, if the denominator is not 0, fall through to this second one, and then do this. Okay. We talked a little bit about ARITY before. So we can have the same function the same function name with many different implementations with a different number of arguments. Okay, so this is one way of doing like default values is just to have one with a fixed default, the single argument. In all the documentation, they're referred to with this slash and then a number, and that slash is the number of arguments it takes. Anonymous functions are always 0 because you have to call them with this dot. Just because. That dot drives me crazy, but it's there. So here we have /1, /2. They have separate do bodies. And this is, again, kind of like that pattern matching we were doing on the previous slide, but it's looking at how many arguments are getting passed in. It will match in both the previous slide and this one from top to bottom. Right? These two backslashes mean give us a default value. So this is still add 3, but default C to 10. But because this works from top to bottom, if you don't pass in this C, it's going to get to add, see the two arguments, and not know about this one, and just add these two. So it's a bit of a gotcha. Okay.
So can you explicitly call a method with, like, can I call like add /3, and then it'll, if I only supply like 2 arguments, it'll still call that very last one and use the default?
Yep, absolutely.
Okay.
The other way to do that is the one that I showed you. That's not actually technically in a slide, is you can put an ampersand before the argument, and then whatever you want to pass in, or whatever you don't want to pass in, is &1, &2, etc. Just like argument 1, argument 2. You can also do that to flip the arguments if you're passing in an anonymous function. Say, ampersand foo, ampersand 2, comma, ampersand 1, right? Pipes. This is one of the, for a lot of people, a defining characteristic of Elixir and something that makes it feel very Elixir-y. It is certainly not the only language with pipes, and it didn't invent them. But it is a difference from Erlang. Right? This reorders the flow of functions. I like to say that it linearizes function calls, because we take this densely packed thing and then say we do this, then this, then this, then this, then this. Right? The way this works can be a little bit confusing, especially at first, and even more so if you're coming from some other languages that have pipes, especially Elm, because it pushes it into the first argument, not the second. So this last one here isn't integer.floordiv3, comma, whatever the result of this is. It's the result of this, comma, 3. So we think of this as a subject being piped through and always in this first position. It makes it, I think, a lot more readable than something like this, which is very dense, right? But at the end of the day, this is a macro. This hits the compiler, and it immediately gets turned into this at compile time. So to the compiler, or to the runtime, it makes zero difference. It is purely there for the programmer. So using that enum.map version we had before, for example, right? I could also write this as that. The nice thing here is we can keep piping afterwards, right? Enum dot, I think it's count, maybe? Yeah. So if you're coming from an object-oriented language, this is like the dot chaining, but we have an operator in the middle instead. I like to describe this as an assembly line, right? We take something at the beginning that is our subject of the pipes. We pass it through several functions, and that composes together to become a larger function, a larger computation. Now, if you're coming from a language that has true function composition, you don't get function composition out of the box. You have to call it with an argument or wrap it in an anonymous function. If you want regular function composition, there's a library called Quark that provides that, and a whole bunch of other standard functional programming things like that. Pipes are really easy to abuse. Please never write this. Okay? It actually makes it harder to read. It's more characters, right? It's much clearer like this. You also don't have to do the mental gymnastics of thinking, okay, so if this has, whatever, 4 more arguments on it, is it the first value or the second value, or what am I seeing? This is just clear. I'm calling integer to string on 45, and that's it. I just gave an ad hoc example of this in the terminal, but these are also equivalent. So saying integer.digits 1, 2, 3, 4, 5, pipe that into a filter, or saying 1, 2, 3, 4, 5, take the number of digits, or sorry, split this into digits and then filter them out. These are the same. Again, please never do this. It's confusing, right? Because I'm going to see a large chain of pipes. This could be, say, 10 long. And I'm reading along this side of it, and I think this is the second argument because I see all those pipes on the side, right? Always reorder it to this if you have a bunch of pipes. There's now, as of a couple months ago, a formatter in Elixir that comes out of the box, mix format. It'll format your project, and it'll do that for you, right? Like it will not let you do this. It'll force it into that. The other advantage of using pipes is it's very easy to put something in between, right? So that io.inspect is great for debugging because I can just pop into anywhere in here and put another arrow and io.inspect. It is going to print to the console and return that value again, and that value gets piped into here. So it's basically a no-op with a log on it, which is kind of nice. Pattern matching and destructuring, which is getting a lot more common now. We have it in even JavaScript now, some of this. So we still have simple assignment for variables, something that most of the people, when I was walking around, were already doing this with the turning lists into strings exercise. We can just say a equals 1, it's 1, b equals this, this map, fine. This is not a referentially transparent language, so you can reassign a at will. So we could then later say, a equals 2, and it's not going to complain nothing. You can just a equals 2. It's fine. I would say that's probably not a best practice, but you can.
Are there immutable keywords? Like can you do val, a?
No.
You can't do reassign?
No. Yeah, you can reassign whenever. So this is another one of those times where it's like, oh yeah, okay. When they were designing this system, like in the 80s, they didn't set out to write a purely functional, system or even an actor. They were working from very pragmatic. We're trying to achieve this goal for Ericsson on high-performance network switches that work this way, and this is the kind of code they were writing. Yeah. So do I think it's a best practice to not reassign variables? Oh yeah, no. That's like the number one thing I write in code reviews. Stop reassigning your variables, right? I want to be able to read this very easily. But even in the docs, Jose writes it, they'll do a equals a plus 1. I'm personally not a fan, but you can do that. Multiple function heads we looked at with back when we were looking at defining modules, right? But for example, this is we can do it also with anonymous functions. So this is that fn, and then we can just define a bunch of function heads on it, and it'll do the same thing. It'll match from top to bottom, exactly this. We can match now, split out the head and tail on that list, that linked list, pull out the h, and then use it on the right-hand side. And that'll work. Right? So now when I call head on 1, 2, 3, I get 1. In this case, we're defaulting to nil. If I passed in that with an empty list, it would put nil. These don't have to be just single values, though you always have to return a value. You could have, in the middle here, pushed this down to the next line, logged, written something to the database, whatever, and then passed back the h. Now there is a runtime cost to having these multiple heads. It's low, which is nice. It will read through its argument until it, as far as it can, until it doesn't match, and then drop down to the next case. And it also does some nice optimizations on it too, but it still will try each case. So if you have, again, please never do this, but if you have 50 of these and your case is at the bottom, it's going to have to match on all 49 before it hits the one that will work. Usually it's like 2 or 3 of them, but there's a small cost. Now, we were saying that functions, defined in a module can have different arities. Could I have different arities in here? No, right? Because it only can work on the arguments being passed in. If you want 2 different arities, you need 2 different anonymous functions. Right? But we can still split it apart and grab the value, right? We can also assign the same way. So if I mirror, So we have pattern matching assignment, destructuring. In this case, if I want to get out into, say, the second value, I'm going to have to do the whole right, the whole thing. Or if I have some nested structure, oops. Right, so we can, destructure pretty deep, well, as deeply as you want, arbitrarily deep into a structure. The one that we're going to be looking at quite a lot in a bit is something that looks like this, right? So it's a tuple, very, extremely lightweight, just 2 pointers sitting next to each other in memory. And this OK says only match this if I get back an OK atom. We use those as signals. Right, so I can say, OK, x, and my x is 1. If I get back anything else, it blows up. There's no return operator function. If you want to get out of a function, you have to return some value. And this forces us to really show the tree, to show the branching. So we have this handy little function case, or I guess control structure case. We're going to look at this triple. I'm going to drop down to the first one, pattern match out something. Second one, only if the first one is 2, return 2, otherwise give me other, right? In this case, I have A in the second position. We don't care about the first. We just grab that something, which is foo, and return it, right? So you can't do these, guard statements that you might be used to from other languages, right? You have to show explicitly this is the tree, this is the decision tree every time. Case underneath is actually just an anonymous function, which is how it's doing that pattern matching. It's just like a self-calling anonymous function. You don't have to do dot and then pass in some arguments. You can just do it in place, which is very nice. It also means that you can pipe into it. So if we have this long list of pipes, we can just put a pipe in front of this, ignore that bit, just have case do, and then do our matches, and then do that to split out our decision tree. Okay, mixed matching. So in this case, this is that pipe into a case do that I was telling you about. We can pull out in the function match there, match here. So in this case, I have default is going to be bad, and then this dot dot is a range, and this underscore just gets erased at compile time. This is just for your own use to break numbers where you'd put a comma in writing. I now have that number list. I'm going to count the number of elements in this range. Divide that by 10 and take the floor. And then if it's 1, return 1 as an atom, 2, 3, otherwise my default status, which is that one. Right? So we can do this mixed matching, scope applies, that's all fine. Right? So the end result of this one, anybody want to take a guess?
That 22.99,000, does that expand out to a list of 22, 23, 24?
Yeah. Yeah. It stays as a data structure just range for space until you try to do something enummy on it, and then it'll turn into a list. Yeah. but like for all intents and purposes, yeah, it's a list.
Okay.
Yeah,
Anytime you use it.
yeah,
Okay.
yeah.
Bad.
Yep. Yeah, exactly. Right, because we're going to have several thousand of these. Even when I divide that by 10, that's more than 3. So we're going to get the default status, which in this case is bad. Else if is something that we do not write. This is immediately refactorable to the version on the right. This is valid syntax. You can do this, but this reads a lot better, right? The difference from case, right, where we have a default, we're saying match anything, is because these are if-elses. It's going to evaluate each of these into a Boolean, right? So true always matches. If true is at the beginning, it would always go to that and ignore the ones below it. There's again a runtime overhead here because it has to run each of these functions as it runs down the list to check them. So if they're very lightweight, great. But if they're a bit heavier, they need to talk to the database, whatever, maybe consider refactoring because now you're going to have to do all of these checks, right? So you had a little bit of practice with this. We're going to write a little magic trick. I realize that this is a bit of a, a toy example more than anything. Actually, is that readable? Yeah, it should be readable. So it's one of these, taking advantage of some cute thing in math, run through all of these steps, and ask people to, think of the name of a European country that starts with that number, but it'll always be 4. Write a module with a function or functions, break them up as you like, that runs through all of this, and then checks if people have entered our guess for it. So again, feel free to approach the problem however you like. This could be done as one big chain of pipes. You can break out, especially some of these later steps with the validating correctness. It's a nice case for pattern matching, a lot of them. So you can either pipe that into a case or break it out into its own function.